Large language models are powerful, but they have an important limitation. They can hallucinate, rely on outdated information, and they do not have access to your private or enterprise data. In this video, I'll explain Retrieval Augmented Generation, or RAG, using simple language, clear diagrams, and real-world context. As organizations adopt generative AI, accuracy becomes critical. Large language models are trained on public data that is frozen at a point in time. They do not automatically know your company policies, internal documents, product manuals, or customer records. When a model is asked a question outside its training data, it may generate an answer that sounds confident but is completely incorrect. In enterprise systems, this creates serious risks related to trust, compliance, and decision-making. This is exactly the problem that Retrieval Augmented Generation is designed to solve. Retrieval Augmented Generation enhances a language model by injecting relevant external knowledge into the prompt at runtime. Instead of relying purely on what the model remembers from training, the model reasons over real data retrieved dynamically for each request. Let's look at the architecture at a high level. A user submits a query through an application. Instead of sending the query directly to the language model, the system first invokes a retriever. The retriever performs a semantic search over a vector database. This vector database stores embeddings of your documents, such as PDFs, internal wikis, knowledge bases, or support articles. The retriever identifies the most relevant content and sends it back to the application. This retrieved context is then added to the prompt before it is sent to the language model. The language model now generates a response that is grounded in real, relevant information rather than guessing. Here is the step-by-step flow. First, the user submits a question. Second, the retriever finds the most relevant embeddings from the vector store. Third, the retrieved context is injected into the prompt. Finally, the language model generates an answer that is accurate and context-aware. This approach dramatically reduces hallucinations because the model is no longer relying solely on its internal knowledge. It is responding based on real data provided at inference time. That is why RAG is especially well suited for enterprise use cases. Common use cases include internal knowledge assistance, customer support chatbots, compliance and policy question answering systems, and enterprise search applications. Any scenario where responses must be accurate, explainable, and up-to-date is a strong candidate for Retrieval Augmented Generation. However, designing a RAG system requires careful consideration. Chunk size affects retrieval quality. The choice of embedding model impacts semantic understanding. The vector database selection influences performance and scalability. And there is always a trade-off between latency and accuracy. To summarize, Retrieval Augmented Generation grounds large language models in real data. It is a foundational design pattern for enterprise generative AI. And in most real-world systems, architecture decisions matter more than the choice of model. If you are learning generative AI or preparing for AWS certifications, check the link in the description for free learning and practice resources. Thanks for watching.